Did you enjoy our previous video on how to quickly get started with coherence and network a character in 5 minutes? If you haven't watched it, we suggest you pause this one right now and watch that one first. Now with those basics in mind, it's time to have some fun. In this video, we will build on top of that demo and network a vehicle with both a driver and a passenger. Like the characters in the previous video, we're going to make this vehicle client authoritative, so without using a server. This will allow us to get a first look at some fundamental coherence concepts: authority and how to transfer it using requests, unique entities, persistent entities, and network commands, aka RPCs. Are you ready? To start things off, we're going to begin by using a version of this vehicle that is fully functional but totally offline. Let's take a look at how it's put together. The prefab for the vehicle features a number of scripts. The vehicle controller script acts very much like your typical character controller. It takes inputs from an external source and puts the vehicle into motion by using forces on its rigid body and repositioning its wheels using raycasts. The vehicle script acts as the brain. This is where the player's interaction script will make its requests to interact with the vehicle and ask, "Can I take control?" or "Can I be the passenger?" When the player approaches the vehicle, the player brain script performs a raycast. When it finds a vehicle, an outline tells the player if the vehicle can be driven or not. If the player presses the interaction button, their character is parented to the vehicle, its input script is turned off, while the vehicle input script is turned on. That's it, we kept it very simple. You don't have to break the logic down into different scripts, but it's good practice. This will make it much easier to transform this vehicle into a network object later on. Now let's make this vehicle networked. As a first step, let's transform it into a networked object. We just add the coherence sync component and we're good. However, if we plan to have the vehicle in the scene and not spawn it at runtime, we need to change a couple of things. Because you see, if we bake the netcode and we start the game as it is, we will see the vehicle being duplicated by each connecting player. This is because if this network entity is not marked as unique, coherence will bring a fresh new copy for each player. Duplicates are desirable for a player character prefabs because we need one for each client, but not for an object in the scene that we want all players to see as a single instance, such as this vehicle. So on the coherence sync, we want to make sure that this network entity is set to no duplicates. The prefab instance unique ID, automatically generated by coherence every time we duplicate this prefab instance, will make it so that multiple instances of this vehicle in the scene will all have their unique ID. In addition to that, we need to set this entity as persistent. As a persistent entity, even when the current authority leaves the game, the car will not be destroyed, but will be left behind. The authority, thanks to this setting here, auto-adopt orphan, will be then automatically shifted to another connected player. To complete the setup of this network prefab, we can use the configuration window and set a few properties to be automatically synced by coherence, on the root object and on some of its children, specifically the wheels. Let's network the ability to become the driver of this vehicle. Becoming the driver means we want to control it, which, in networking terms, can be easily translated to becoming the authority for this network entity. We want to implement these changes in the vehicle script. Let's add and retrieve a reference to the coherence sync component attached to this prefab. Now, where the player requests interaction with the vehicle, instead of confirming it as the driver right away, we want to insert an intermediate method. Let's call it try@driver. In here, we want to first verify if we already have authority over this vehicle, because if so, we can confirm the local player as the driver right away. If not, we want to perform an authority request. Now it's time to start thinking in networking terms. This car exists in the Unity scene of each connected player, and this script is running on all of them. So we're going to need to write code that needs to execute not only on the local player's end, but also on the remote player's side. When we perform this authority request, we want the remote copy of the car to respond. So we create a new method called onAuthorityRequested. This method triggers on the authoritative copy of this car if we have configured its coherent sync to have authority transfers to request. Let's remove auto-approve because we want to reply with some specific code. In this method, we can now return true or false based on whether authority can be transferred. Let's do so based on whether the car currently has a driver or not. Now we can add a listener to it in the onEnable. Now back to the requesting side. We request authority, whoever has it agrees or not, so now we want to tap into the onStateAuthority event of the coherent sync and prepare a method to account for that. We name it onAuthorityGranted, and in here we can finally confirm that this player is the driver. However, 1 second, this event can also fire if somebody who has authority on the car leaves, because we set it to auto-adopt orphan. So when the current authority of the car leaves, the authority is automatically passed to somebody else, which will trigger onStateAuthority. So let's add some safeguard. Only if we have explicitly asked for authority to become the driver, we add the user as a driver. In fact, if we were not awaiting authority and someone just left us the car, then it most certainly has no driver, so we better set its hasDriver property to false to here. Voila! Let's also add a listener to the onStateAuthority in onEnable and use this method as the callback. Now let's react to the case when the authority request comes back as negative. We want to implement a listener to another event onAuthorityRequestRejected and invoke rejectControl, which will inform the player brain script. We also want to reset the state of awaiting authority. Let's test our gameplay so far. Ensure we baked. Launch the local replication server. Press play and connect. When the first player joins, they spawn a character for themselves and, because they see the car first, they become its authority. We can easily verify that by checking the car's coherent sync inspector. The player can simply become the car's driver without any exchange of network traffic. They are already the authority. When the second player joins, the car doesn't get duplicated because it is a unique entity. When they try to enter the car, the authority is requested and immediately transferred. Notice how fast authority transfer can be. If two players try to request the car at the same time, then the authority request mechanism will determine who gets it. It's the replication server who decides based on who did the request first. The one with the lowest latency gets authority and becomes the driver. When the second player's request for authority arrives, it will fail because the current driver has now set its hasDriver property, so the request gets rejected. So this logic is now in place and it won't fail in case of multiple requests being emitted at the same time. Now let's improve this interaction a little. You will notice that because we're relying on a private variable hasDriver, we might see the vehicle as available even if someone else is already in it and only be denied when we make the request, and that is not nice. We can patch this quite easily by making hasDriver a synced variable. First, we make it public, this is a necessary step. Then we can mark it as synced either from the UI or even in code using the sync attribute. Back in Unity, we bake the netcode and restart the replication server. Now, because the parameter is synced, the first time the authority sets it for themselves, it will be propagated to other clients. When someone now tries to highlight the car, it's immediately highlighted as not available, improving the player experience. Remember, networked gameplay always implies a delay, and that's why you really need to provide good feedback of every player action at the local level. Let's see now how can we add a passenger to the car. When a player joins a car as a passenger, they don't need to take authority over it. What we want to do is simply to parent the player to the car and perhaps change camera or even activating the same camera as the drivers. But just like for the driver, we need to ensure that two players requesting to enter the car at the same time won't break the gameplay. First, let's create some state variables for the passenger. we can pretty much follow the same logic as before and prepare some stub functions. But when it comes to ask the owner of the car, we don't request for authority, but send a network command. Essentially, we expose a method to coherence and we allow it to be called over the network. We can prepend this method with the command attribute, which, very much like the sync attribute, will automatically expose this method as if we marked it in the coherence configuration UI. This is the syntax to send a command. First, we want to invoke the method with the type we're looking for, so coherence knows which script needs to receive it. In this case, the script is vehicle. Next, we add the name of the method, then the target of the message. We want to ask the authority because only they have the latest reliable state of has passenger. Now let's go to request boarding as passenger. In here, we can reply. If the authority car has no passenger, we can confirm. But from the point of view of the authority of the vehicle, how do we find the client who requested it? There's a couple of ways. The simplest, perhaps, is to pass a reference to a coherent sync that represents the network entity of the player character requesting. So let's step back into the player brain script for a second. Here, where we invoke request interaction, we can pass a reference to the coherent sync to the vehicle script. Now in vehicle, we modify a request interaction to accept the parameter, and we use it in turn when we try to become the passenger. We add it as a parameter here too, and pass it as part of the network command invocation. And of course, modify our network command to receive it. You see, coherent sync references are valid data to pass over the network because coherence is able to track which entity they belong to. So in this case, upon receiving this command, it will be able to track the correct component in the remote player's world. At this point, from the point of view of the authority car, we can use the coherent sync reference to respond to the correct requesting player. Let's create a method in player brain and mark it as a command. We can give it a boolean parameter, which will represent whether the player has been accepted in the car as a passenger or not. So now we can fire it from the car with the appropriate response. And set it to be true because in any case, at the end of this method, the car will have a passenger. The only thing left to do now is to create the functionality in the player brain to sit down the passenger in the car. Well, there's also some cleanup we should do. For instance, if we leave the vehicle as a passenger, we should send a network command to the authority of the vehicle so they can update the vehicle's hasPassenger variable. There is more cleaning and refinement we can do, but it's enough for this video. You can download a version of this project without the graphic if you want to explore the scripts more in depth, linked in the description. This was just a quick tour on how to create network logic in coherence using authority and authority transfers, network commands, and synced variables. We hope you enjoyed it, and we invite you to check out our other videos and our documentation to learn more and explore all of the cool features in coherence. If you want to be notified about upcoming tutorials, subscribe to the channel. Until next time.